can start.
Yes.
Okay. So today I will give you a demo on Wireshark. You need to start the Wireshark with sudo level permissions. Without sudo level permissions, you won't get the interfaces gonna you won't the interface are not gonna show up here. So as you can see right now, it was not showing any Wi-Fi, Bluetooth, and loopback addresses. I'll close this. Now I'll start the Wireshark with sudo level. Okay, now you can see, well, turn on this. Yeah, now you can see you know, the interface has came up. WLO1 is there, right? This is the Wi-Fi, and any means it was showing all of the three. This is a loopback, which is which will be used for internally, and this is the Bluetooth, and you can see the Bluetooth is down. The Just by the image itself, you can understand, right? It was just it was just started, and like it not started, it was just went down, and there is nothing. It was just same. Whereas when it comes to here in the Wi-Fi, it was up and down, up and down. Okay. So does anyone know about the DHCP? DHCP. DHCP is a client, uh, dynamic host client configuration protocol. Am I audible? Hello.
Yes, Sharath, you're audible.
Yeah.
Yes, sir, you're audible.
Yeah. So how when it gonna start up means when the moment when you turn on your Wi-Fi, right? The moment when you turn on your Wi-Fi, first it will look. A computer needs an IP address, right? So the moment you turn on your Wi-Fi or for any network connection, you need a Wi-Fi. So this, I mean, sorry, you need a IP address. The IP address will be previously we used to set in the olden days we used to set it manually, but right now we are automatically get assigned the IP address by the DHCP port server, DHCP server. So how this DHCP all those things working now we're going to speak. So this is a previously captured packet. Why I have captured previously means because right now if I turn off my, I mean only when I turn off my Wi-Fi, then only once again the DHCP request, all those things gonna happen. So if I turn off my Wi-Fi, the connection will be gone. So that's why I didn't. Previously, I have captured the packet and I'm doing the following. So this is a Wireshark interface, and I'll just give you what are all the above things. This is you use for start capturing the packets, and this is for stopping, and this is for restart the capturing. And here is options like you do the settings, and here you apply the some filters in this below. You can see, right, a tag like option. Here you will apply the filters and close the capture file and reload the capture file. And these are nothing but the zoom and more coloring options. You can even color the tools, and there are some more advanced. You can add it here. Okay, I will zoom it. So right now I'm gonna apply the DHCP filter. DHCP. Just type it and press enter. Yeah. Now you can see. Now you can see is only limited number of packets are displayed. So this conversation in total, it has a 388 packets in total when I captured the data, and out of those only 9 packets are DHCP packets. Okay, you can see it, right? And as you can see, DHCP is the first packet. You can see the number is 1. Maybe even if I remove it, I'll press enter. And total here 388. If you go down, like, there will be a lot of other packets. But the first one is the DHCP, because without an IP address, you won't get any data, or you can't do anything. A system needs an IP address by default. So this is the first packet. So whenever you turn on your, whenever you want to get an IP, the DHCP gonna start the conversation like this. First, you're gonna send the following protocol, following packet, DHCP discover. Okay, DHCP discover. And here, but before that, you can see there is some request and DHCP NAK. NAK means negative acknowledgement. So why it was showing like this means, because what while capturing this packet, what I have done is I just turned off my Wi-Fi and right away turned on my Wi-Fi, turned on and off. So the moment it just got like that, at the time it was since it just turned off and came back, right? It was just asking for some specific request. It was just asking specifically some I need certain IP. So this is the packet. And these are the sequence numbers, just for your information. And this is the timing in milliseconds. Usually it will be shown in the milliseconds time. Okay, and this is the source IP from where it was getting, from where it has started the packet, from where it came and where it was reaching. And this is the protocol info, which protocol is getting used. And this is the length of the packet, that is nothing but data. So let me click on this packet 1. So here are the frames. So right now our interest is in the DHCP, Dynamic Host Configuration Protocol. Okay, you can see here, yeah, you can see a small arrow pointer, right? You just click on it, so it will be expand the options. Okay. So here there is a draggable option. Like here you can see when you click on the packet, you get more options, right? The information. You click on, you keep your cursor here, and you will see a kind of cursor got in a different shape. Pointer has been in the two-way. So now I'll drag it for above and down. So this is the one. So here you can see it is a request. A request means it goes from the client to the destination. So here the message type, it was showing it as a request. I'll explain all of the parameters here. So here it is a request and it is coming from the Ethernet. I mean, Ethernet, and hardware address length is 6, and how it is 6 means I will show you. Yeah, here each here you can see each value is there, right? Like a 15, 13, and each one is in the form of byte, 1 byte, and the total how many bytes are there? There are 6 bytes. This is the hardware address. Okay, and these are the hops, like from before this packet got captured by this is, like maybe I'll show you. Yeah. So for suppose here, if here I am the one and I'm capturing the packets, so from here to here it is the hop 1. Here it is will be hop 1. But here, right, wherever it was the source is happening, right? Here is the one which is generating the packet, and here is the one we are capturing the packet. So the hops will be 0. If I start to capture it from here, and the hops will be like for example, the packet has started from here. This is a hop 0, hop 1, and hop 2. So how many hops has been happened? It's gonna be shown there. Okay. So right now this is the source one from the from my laptop itself. I generated the DHCP packet, and the from in my laptop itself I have captured that packet. So that's why you can see the 0, hops are 0. And here you should notice this for every you know, for every a new transaction, like for every new time trying to get a DHCP IP address, for every time you try to do a action of getting a new IP address, it's a nothing but a sequence of steps. So every sequence of every transaction will have a unique ID. From here you can see this transaction ID from here to here, completed transaction will have a, these 3 transactions will have a complete same unique transaction ID. Whereas so from here it was done NAC NAC, NAK NAC, negative acknowledgement. So there it is, the transaction is completed. Now here is a new transaction has started. Discover, right? DHCP packet information is DHCP discover from here to here. All these are like related to only one action, like starting from requesting, like looking for the any DHCP servers are there, and the server is offering you a IP address, and the client also says that I will taking that IP address, and here acknowledgement means the server also gonna give you like saying that okay, I have allocated this IP address to you, this information. That is the information. Yeah. So these transaction, I mean, I hope you got the transaction ID, the path, and the second select, like how many seconds this how many second it has waited, and it is a unicast. It was saying this as a in the parenthesis unicast. What it means here, you should notice one thing: the source IP address is 0.0.0, and the destination IP is 255, 255, 255. Does anyone know what this means? Okay, 255, you can see, right? 255.255.255. This is a broadcast destination. Like we are saying, we are sending it to sending the like shorting out to all the devices in the current network, not just to any specific. We are just shouting. Like right now, the in the DHCP protocol, this 4 zeros will indicate that I don't have any IP address. I'm looking. I don't have any IP address. This information. Right now, as of now, it doesn't have any information, any IP address, and it was spreading the word to all the. Does anyone? I need this packet information. It was just asking to everyone. Okay, and here it has given as unique. I mean unicast. Unicast means it was just saying the DHCP server. You can instead of us broadcasting, you can also send it to me directly, uniquely send it to me directly. Okay, so the important part is these 4 things. Here you can see it, right? Client IP address 0, all the 4 zeros, and once again your IP address is all 4 zeros. Next IP address is 4 zeros, and the relay agent IP address is 4 zeros. Okay, I'll go through all those things in the forwarding. So right now the following client IP address 0, it indicates that I don't have any IP address, and even the same information. And right now the communication is happening using the MAC address. Right now you can see this is the MAC address, and these are information is not needed, and yeah, this information is not needed right now. So here we are requesting the following type. What is this option 53? So here what we are doing, DHCP, it is a request and identifier from where it was getting from the Ethernet, and this is the MAC address where it needs to be sent, like a physical address. Like does anyone know the properties of MAC address? A MAC address is a uniquely assigned hardware address, which is unique to each and every device. It can't be any matching with any other device. Of course, you can set the MAC address also by using the MAC changer command. Yeah. So these are the option parameter request list. So whenever it was requesting, it was also asking if you have give me even this information: subnet mask, and time offset, and a DNS server, DNS server, it is used for domain name resolution. Like when you type Google, right, it won't be automatically turned into IP address. The request will be sent to DNS server and host name. I need the host name of the DNS server and the domain name interface maximum interface MTU, like the maximum transmission unit, like how much size packet can I send to you directly, and this is the broadcast address. If any packet I need to send, to which address I need to broadcast it, and these are some extra information. Route and static route. This is like a optimized part. You set a one static route so that you don't need to go left and right like this way. You just follow send the packet right away in the static route. It will be fast. And network information, all those things it was we are asking while it was sending, while it was requesting, and from where it was going, source to destination. That means from our laptop, from current laptop, it was broadcasting to this whoever. Is there any DHCP server? Is there anyone available? While giving, if you are available, while giving your while giving me sending me an IP address, also give me the following information, and NPT and NTP server, network time protocol, all those things. So here it was saying maximum DHCP size I can accept is this one. And previously, previously I have said that, like previously I'm having, this is the IP address. You can see 10, the moment you see 10 dot, can anyone say what type of address this is? What type of IP address? It is a private IP address of class A. Okay.
LAN, no, sir.
Yeah, I mean, LAN only. It's just you say, yeah, internal. It was a private. You can set this 10. You can easily see this 10 dot IP address in multiple computers, like in multiple organizations. This is only IP address like a 10 dot, and then the rest here 02 to 255. It can be used for any number of devices using one single IP address, single public IP, and this is maybe I will, this information you will learn in the upcoming weeks about NAT. Those who maybe just to do a NAT, search on the Google about NAT, Network Address Translation Protocol. Then you will understand this, how this multiple different systems are having even same address, same IP address in different organizations. Still, you are getting how it was uniquely getting identified in your system. Yeah. And here you can see the length is 4, the IP address length is 4, and here it is length is calculated. It was each one is a 1 byte. Okay, 1 byte. And we are even requesting, we are, while sending our while sending this packet, we are even saying this, the host name, my computer name, that is the Ubuntu, and the number of characters you can see it is easily 6, and it was the same one. And this is the end. It was just showing this is the end. Now we what this I forgot to mention this. I have my previously before turning off and on. Previously, I have this IP address 10.44.51.116. I'm just requesting, can you give me this IP address? It was a request, went to the DHCP server. Now you can see the next transaction. Here you can see by the transaction ID itself, you can find out which belongs to which. Because here you can see here DHCP is request, and here is another request packet. Then how would you identify which one belongs to which using the transaction ID? Okay, so here is a NAC, I mean DHCP NAC. So the DHCP server, this is the DHCP server IP address. Actually, this is not a DHCP server, middle DHCP server, like a relay. Maybe, yeah. For example, let us consider this as a router, okay, and here is the DHCP server. This is the centralized DHCP server, okay. This centralized DHCP server is the one which is gonna manage the IP address allocation, all those things. But your computer is not directly connected to this way, to this direct router DHCP server. Instead of that, there is a middle one. This is the relay agent. You can say relay DHCP server. Nothing but one of your router which is nearest to your laptop. You are connected to this one, and this is the middle one is there. Okay. Yeah. So that IP address, that middle one IP address is the following information. And once again, this source IP address, like this DHCP server is broadcasting to everyone. Okay, because why everyone? Once again, because the client does not have any IP address. So once again, it was broadcasting. So now you can see here message type is reply. Previously it was a request. Okay, previously it was a request. Now it was a reply, and it was a reply, and it was same information. Ethernet it was going and the same transaction ID. If you consider previously it was hops is 0, now it was 1. Why? Because see, hops. This is from the client, like my system to the DHCP server. I'm trying to, I need a IP address, I'm just requesting. And it started from my captured in my system itself. So that's why hop is 0. Whereas when it comes to the DHCP server, I took the packet. Now it was hop is 1. That means you can understand here is a there is a one middle DHCP server in between the real one and the client and the my computer and the real DHCP centralized server. Okay, and once again this is the same information. Yeah, once again you can see I don't have any IP address, and same here information. And this is the next server IP address. This is we'll talk later. And you can see a relay agent IP address. This is the middle one IP address. This is the middle router IP address. That is the IP address 10.44.51.254. That is the middle one. Okay, and we are saying our my system Motorola. This is the IP address, and this is some extra information. And here now let us see. Now from the server, I got a message that NAC, negative acknowledgement. That means I cannot have that IP address because there are few more reasons. Like either I have exhausted the time. Like whenever a IP address is allocated to you, like a certain time limit will be set. Okay, like 8 hours, 4 hours, 10 hours, like this kind of information. This I will allocate you this IP address for 8 hours, or else the moment you got disconnected, and the other system already like took your IP address because you just got disconnected, like this, or else your MAC address has changed. Like if you change your MAC address, so it is a new device, so a new IP address will be allocated to you based on your MAC address. Okay, so here we got the snap. That means I cannot give you the you asked IP address because it was already taken by some other one. Okay, and DHCP server identifier. You can see it, right? Previously here it was 10.44.51.254. From here I got this message, but why am I seeing this different IP address? DHCP server identifier. The information, the meaning of this information is DHCP server identifier. This is the IP address of the DHCP server, where this is the one. It is allocating each and every IP address, to the connect to the laptops which are connected in the network. Okay, like here, this is the this router's IP address. This DHCP's server IP address is the one which we got here, server identifier. Okay, and here we got here we got the message. The message is requested address not available. Previously I have mentioned, right, I requested that certain IP address which is sending with 116. It was saying the requested address is not available, and the end of the communication. And now you will see here two times back, because while using DHCP we are not using any TCP protocol. Here we are using UDP. UDP, what it will do means it will just send data fastly, but doesn't care about how much times it was sent, or if I just got a request, I'll just send it. I don't care sequence or reliability, ordering, all those things. Okay, from here, the connection has ended. Okay, now here a new cycle has started. A new cycle of requesting for IP address has started, because you can check from the transaction ID. Okay, from current sequence here, packet number 6 to below, all the transactions are having same transaction ID, whereas packet number 12145, those are having different transaction ID. That one belong to the one cycle of transaction, IP transaction request, and this is the second transaction. Okay. Now this is the one. Actually, it's gonna start like this way. DHCP. This is starting from state 0. Okay. DHCP discover. Now our you can see it, right? So from the connection is using only client address, the hardware address. Now it was sending broadcast. It was just saying to all, does anyone have is anyone DHCP server available? I need an IP address. This information. Yeah, forgot to mention about this. Does anyone know this port number 68 and 67? What are these for? Okay. Uh, these are the standard port numbers. Port number 67 is for the DHCP server. Okay, remember this. Port number 67 is for the DHCP server. Port number 68 is for DHCP client. Okay, that yeah. And here we are sending the message DHCP. What type of packet we are sending? Discover. Like we are trying to discover is there any DHCP server available? We are requesting via same Ethernet, all these things, and hops are 0, different transaction ID, and unicast. It was saying that if possible, directly communicate with me. You don't even need to broadcast the same information. Okay. Once again, it's gonna send the same typical previous kind of information. I'm discovering. This message is for the discover, and the same subnet. While you are assigning the IP address, even send me this information, extra information also. Okay. It was doing the same thing, same information. Okay. Now DHCP server, this is the DHCP server IP address. You can see it, right? 10.44.51.254. It was offering. You can see the offering terminals. It was just offering. It was not imposing. Like it was not just confirmed that I'm giving to you. I'm just offering you. Do you like this IP address or not? It was giving the offer. So here it was a reply and the same information which I have explained previously. Now, yeah. So it was just offer and a server identifier, as I said previously. Uh, this is the one which was offering, and IP address. This is the information. Previously, I have mentioned, right? How much time this IP address will be allocated to you? IP address lease time. Yeah, I hope you know the word meaning of lease by the real estate business. Lease is like a taking something for a certain period of time, like borrowing it. So the IP address is allocated to you for 8 hours. Okay, 8 hours. This IP address will be allocated to for me, and this is the subnet mask. These are all the information previously I have mentioned, right? Uh, while I was broadcasting this, I need even this information. Try to give it to me. So here we got the offer, the information same. This is the subnet mask, and these are the DNS servers. These are the DNS servers which are used by the internally, and from where it came, the domain name. Here you can see IITM LAN. Okay, and this is the from router, relay router, which I got information. This information. Okay, and here, which IP address it was offering. Here you can see destination 10.44.51.201. This is the IP address. It was just offering to me. So here you can see 2 times the same offer request. It was, as I said, it was a UDP. On top of UDP, this DHCP is running. It will be sent multiple times. So now I'm once again requesting, like it. Why once again the DHCP request? Why not just accept it right away? Because when I request for a IP address, there might not be any one DHCP server. There can be multiple DHCP servers around me. Like here, if for example, this is the my computer, right? And multiple DHCP servers. All these routers will act as a DHCP servers. So this one will also try to allocate me an IP address. This one will also try to allocate me an IP address. This one will also try to allocate me an IP address. So I need to say this information while even broadcasting this. While broadcasting, I will add this information so that I'm only taking from this router not no need for you to join in the cycle of and don't make the communication chaos like this information. Okay, yeah. So here once again, same here is a request. I am giving it, broadcasting it all. As I said, it was gonna say to all other systems DHCP server, and these are the same information. I don't right now the while it, as I said previously, while in the DHCP 00 means I don't have any IP address, but I'm saying it to all other one. Listen, yeah, this is a request, and these are the information I'm getting, and these are the things. I'm taking this one. You can see, right? Requested IP address. This is the one, and the requested IP address. Yeah, sorry. Yeah, this is the requested IP address. I'm taking this address from this server identifier. So now the all the other servers, DHCP servers will be there, right? They will be stay quiet because he's saying that I'm taking from this one. So those other things won't interfere. They will be silent. And this is my information. It was just saying this information. So this is the, as I said, DHCP main server identifier. And right now, the system will get the IP address of 10.44.51.201. So it was requesting, like it was just saying this to all. So now only the certain server, DHCP server, will acknowledge this. This is the acknowledgement. It was saying this, okay, you got this certain IP address. Like it was saying to you, I'm giving it like acknowledgement. So now you can see, the destination as IP address. Previously, it was no IP. Now it has a certain IP. So now the communication is starting with the IP address. Here you can see the type of message. This is acknowledgement. Same for the previous request. This is the request. For this request, they are getting acknowledgement, and same previous as information. Client address. Yeah, my client address right now it is 0, and I'm getting this IP address 10.44.51.201. This is the same IP address which is getting allocated to me. And the next server IP address, this is the DHCP server IP address, and this is the relay agent IP address as previously said. And yeah, here we're gonna come DHCP message type is acknowledgement, and identifier, this is the same previous information, and these 8 hours I'm getting this IP address for 8 hours. And these are the DNS servers, same IITM lab and router. These are the information. So now you can see DHCP got IP address is allocated to the system, to my computer. This is the IP address. Okay. Does anyone have any doubts? Okay. Now you can see the packet sequence number is also in the different states. Some of them will be missing, like because while it was trying to do a connection, trying to do a DHCP connection, it will also do other packets. It will also send other packets. So now what I will do means I will remove this filter DHCP, and I'll press enter. Now I will get all the other sequenced packets. Okay. Yeah. After this DHCP server, now what you will notice means, yeah, after the packet number 10, yeah, from here it was completed, right? So our DHCP configuration, like right now I got a IP address. Until packet number 12, I got IP address. But once again, still you can see it was still doing the broadcasting using the hardware address. Using the hardware address, we are still once again broadcasting. Why? Does anyone have any idea?
Again, it is still not connected, so it is keep on asking. Is broadcast?
No. It was connected.
So acknowledged already. Okay.
Yes.
10,
Now,
12 is acknowledged. Okay.
yes. Now what it was trying to do means, now the device, my computer, will not just blindly accept the IP address and assign this IP configuration. All those it won't do the setting. Why? Because sometimes the DHCP server might have the old data. So the IP address might be using by other system. At the same time, it might also even given to me also. So two systems will have the same IP address. Before assigning me before taking that IP address, it was just checking with the others in the system. Okay. Maybe I'll close this time. Yeah. So this is my hardware address. Using my hardware address, we are broadcasting, sending it to everyone using the ARP address resolution protocol. Here, you can see it, right? Who has 10.44.51.201? It was asking, even though the IP address is allocated to me, why am I asking? It is called ARP probing. So we are just asking, is there anyone having this IP address? So if I get a reply, that means this IP address is used by some other guy, so I cannot use this and set my configuration. So it will just send this packet like a 2, 3, 4 times. If I didn't receive any reply, that means it can safely assume that okay, this IP address is not used by any other. I will assign this IP address to my system and set the configuration. The OS will set the DHC like previous information, right? 8 hours are allocated to me. DNS servers are 10 dots. Two DNS servers are IP address is given to me. Those information. Once these 3 times are done, now you can see with respect to this packet, you can't see any arrows. But if I click on the above, like here, you will see some arrows, right? Okay. Here I'm talking about here. You can see the arrows. If I click here, you can see some arrows. But here you won't notice any arrows because you are not getting any reply. Only if you get any reply, then that you will get some certain arrow image. Here you can see 3 times has been probed. My system has sent 3 times a message. Doesn't anyone have this information? Yeah, maybe I'll expand this information. Yeah. This is the information. It was just protocol IP4 and is probe. You can see is probe. Probing means it is asking, does anyone have? And you can see once again it has set the sender IP address as all zeros. That means I don't have any IP address, but I am targeting this IP address. Are you available? Like, are you present? This IP address. No one will reply because this IP address is not allocated to anyone. So the system will assume, my system will assume this IP address is not used by anyone. So I can safely set to my system now. Okay. Okay. Now so these are the main important points until the DHCP setting. Did you get the DHCP point? Like how it was set, all this information?
Sir, yes, sir.
Yeah. Okay. And these are some extra information like once you are joined to the group, you are just saying this, I want to join part of your LAN group, like a local network group. I want to be part of the local network group. Please add me this information. And here you, once again, using your hardware address, you are broadcasting like is gratuitous, is announcement true. That means it is just announcing that my IP address is this one. If there is any other IP address system, same system, like any other different system has the same IP address, then it will won't take this IP address. It was just broadcasting, so other DHCP servers knows. They will update that table, DHCP table, routing table. This IP address is related with the this hardware address. Okay, this is the part. From here onward, the remaining things are DNS and TCP, MDNS, multicast DNS. These are the extra like next communication. Like from here onwards, once you got the IP address, the communication will happen here. You can see it, right? Source IP address from where it was coming. Maybe let us go with the 201. You can see every time you will see 201 this IP address most of the time. And if there is any like a signal using the Wi-Fi and the communication with the router, it might happen with even sometimes with the hardware devices also. Okay. I hope now you got the how the DHCP works. Now, why maybe you might wonder why should I know DHCP server? Because this DHCP, dynamic host client configuration protocol, it is the one. Without this dynamic host client configuration protocol, you won't get IP address. Without IP address, you can't communicate with anyone. Okay, maybe if I will open my terminal and I will type IP address. IP show. Yeah, I think it was. Okay. Okay, this is my, Wi-Fi device, and this is the IP address which is allocated to me. And here you can see valid time seconds. This is the information, like 8 hours is there, right? Out of 8 hours, how many seconds are valid left for me? Now if I run the same command, now you will see these value will be changed. Okay. See. You can see 26366, whereas now you can see 26338. The time is getting decreased. After a certain time, after the time goes to 0 seconds, the IP address which is allocated to me 10.44. This IP address is there, right? It will be revoked by the DHCP server and gonna give it to the different other new one. Okay. And this is the loop back, which we won't be discussing much. Okay, and yeah, INET6 is nothing but IP address 6. Okay, this is the IP address 6, and yeah, this is our IP address, and to which one we are broadcasting, like first whom, like a packet come out of my system, where it gonna go and reach means first it gonna go to this one, this IP address which I have mentioned, right? The nearby DHCP server. Yeah, yeah, 10.44.51, 10.44.51.255. That is the DHCP one more server. Okay, and WLO is the Wi-Fi interface name, and dynamic means the route will be dynamically adjusted. It is not a static one, and no prefix, right? The same information. Okay, I will close this one, and so now the system needs IP address. Yeah. Now, what is the main thing about this DHCP means? Without this DHCP, we can't get an IP address. Now, if we don't know this information about the DHCP, using this DHCP, you can have some problems. You can also some attacks are gonna happen. For example, let us say I'm in a library and there is a Wi-Fi facility is available. So if I want to make the Wi-Fi unaccessible by the different people, okay, what I can do means there is this thing called DHCP starvation. What it will do means if, how the connection has started first by yeah, DHCP the following information, right? DHCP discover. First, it will using this certain MAC address, hardware address. I will say this. I need an IP address. Give me one IP address. Now DHCP server will gonna give you a IP address. Okay. Now what I will do means using the some kind of automation tool, I will every time change my hardware address. This hardware address I can manipulate it easily. Okay. I will change this IP hardware address. Once again, I will request for new IP address. So how many maximum it can offer? It has a limit like 1022. Right now, where is it? Offer. Here you can see, yeah, subnet mask 255.0. So does anyone know how many packets I can, how many systems I can connect with this network? Can anyone calculate? So 255 means here it is a fixed. 255 means once again here it is fixed. Out of 255, of 255 minus 252, remove minus it, you will get 3. 3 into, and then here you will have 255. So 255 into 3 times, multiply with 3 times. So only the following how many? 3 into 255. These many IP address will be systems can be allocated. Right now 765 computers can get IP address, but if I simulate like this way, like around 765 requests, I will simulate certain by attacking DHCP starvation. I will simulate every time. I will change my hardware address. and request for new IP address. So every time the DHCP gonna give it for certain time. Now what happens every time? It gonna say, I'll give you this IP address for how many hours? I will give you this IP address for 8 hours. So this IP address cannot be revoked uh, from me for 8 hours. So until 8 hours, the whoever want to connect to Wi-Fi, they cannot use the uh, Wi-Fi, those router. I mean, or they cannot use the router. Okay, I mean they cannot get connected to the network in the library. If we request more, like around 1,000 requests are requested, then it will be filled. Like everyone has taken, I don't have any IP address to give you. It will say this is called a pool. IP pool is filled. IP pool, yeah. IP pool is exhausted. IP pool is exhausted. Yeah, IP pool is exhausted. So wherever it can cause this kind of issues, attacks can be done. Like whenever you are taking exam, or it can be library anywhere, one can simulate this DHCP starvation attack, and you can't get the internet. Only that one particular person will get internet. Yeah, you won't get any IP address like this information. And there is another thing, DHCP spoofing. Once this DHCP server is there, right? This DHCP server will be filled, like every IP address will be allocated to different MAC address. Okay. Now the DHCP can't allocate any new IP address. So now what will happen? Now you can place a one uh, spoof, like you turn on your computer and saying it as I am a DHCP server. If you want requesting IP address. Now while it was requesting IP address, now you're gonna send your like a configuration, all those things, like a connect to this. You got this IP address, and this is the DNS servers. So now you give the DNS servers. When they try to go to www.google.com, you are making them connect to some malicious website instead of the original website. This information. Got it? Okay, and now maybe I will show you even with the. I'll close this one, and now we're gonna capture a live traffic of unencrypted one. Capture from wireless interface and start the capturing. Here you can see there are a lot of packets are every time getting transferred. Here you can see it, right? I hope. Why? Because every time this many packets are, maybe I'll stop it here. Now you can see every time why these many packets are sent, because right now I'm doing, I'm sharing my screen. So the internet, so the data from my system has to be sent to certain IP address. You can see only the most of the packets are from here source. Maybe what I will do means I will apply a filter, IP dot source is equals to 10 dot 44 dot 51 dot 81. Okay. Now you can see how many packets. 60296 packets out of 60296. 6,000. Maybe I'll zoom it a bit. Yeah. Out of a 6,296. I mean, let us say it as a 6,300 packets. Out of 6,300 packets, 6,000 packets are nothing but sent from my device. That is from the source. Because I am sharing my screen, so a lot of the data is getting sent to outside. And where it was getting sent, this is getting sent to you know Google server. So let us see who is that. Who is this? Who holds this IP address? So if you want to, yeah, by the way, if you want to take a value, what you can do is instead of typing, what you can do is click here, do a right click, and here you will get the option copy. And if you want to copy, you can copy all visible items. All visible item means it will copy everything from as it is, frame, Ethernet, all those things, but not the internal values. Okay, maybe I will show you by all options. I can click anywhere here, copy all visible items. I just copied all visible items. Maybe I will open the podium. Yeah, here now you can see my well, yeah. While when I have done copy of all options, copy and all visible items, it just copied whatever here is visible, right? Only that information is captured, not the sub parts where it was you can just expand and copy more and more information, right? That can also be copied. So that information is not captured. Okay. Now what I will do means I want to need to copy only certain this IP address option, copy and copy as value. Okay. When you do this value, click on the value, you will the IP address will be captured as a. Okay. Now dig. So using the dig command, you can even find this one. And does anyone know the other tools where you can find the IP address of? Yeah, who is another one? Yeah. So now what I have done? I have done who is. Yeah, who is this IP address? So what information I got? I got this. It is a Google. We know that why it was Google because I am sharing my screen using Google Meet, Gmeet. So that's why most of the data is sent to the from my system to the Google server. From Google server, it will be once again sent to your Gmeet like this. So that's why you can see it was Google. Okay. So yeah. Now I will clear the filter and press enter. I'll minimize it. Yeah. Does anyone have any doubt? Should I continue for 10 more minutes or we'll close the session? Yes.
Sharat, I think we can wind it up.
Okay. Okay.
Yeah. Can I stop recording?
Yes, ma'am.